work for Carollo Engineers, and we do primarily municipal water and wastewater work, and most of it in the United States, a little bit in the Middle East and Australia now. My job is to oversee our advanced treatment technologies, and I'm very excited, by the way, to have a lot of the discussion on the wastewater treatment, and there was biosolids and fantastic stuff. It's very interesting to me, the differences between the industrial and the municipal market, and especially as it applies to moving technologies forward. The municipal market is very hesitant to adopt new things. And that kind of leads me to my single slide, which I've been told there is this technology valley of death. And this was our perception of what that is. You have a multitude of ideas out there, fantastic ideas, and very few of them actually ever get through and become implemented at the full scale. And that's something that I am continually trying to do, is to bring these new ideas forward for our municipal clients. But it's very difficult for a number of reasons. And what I want to do is rely upon these experts here to provide their perspectives on how they have shepherded projects forward, brought new ideas into their fold of how they do business. So let me go back one to our speakers there. You've got their bios in your handouts, and so I encourage you to read them. They're pretty impressive, and they're a fantastic group. I've known one of them for a good bit. Matter of fact, Paul Gagliardo showed me some of the real initial excitement and got me interested in the business back many years ago when he was down in San Diego. I took a tour with him and looked at the membrane and the hyacinth ponds, and that really got me going in the water reuse business. I would like to point out what I believe is our biggest challenge moving forward in the municipal market, and the biggest need, and that is technologies to take wastewater and convert that directly into potable water. And right now that is happening across the United States, some of it intentionally, some of it unintentionally. The intentional projects are the ones that get all the focus, and what you're going to see in the next 10 years is a movement not just from wastewater to potable water, where it goes through groundwater or reservoirs or other natural processes, but you're going to see the movement of pipe to pipe, taking the wastewater, treating it, and putting it right back into the potable water system. Matter of fact, there's 2 projects in the United States that are moving forward with this right now. So anyways, with that as a background, we're going to have Harry Seah. He's the Director of Technology and Water Quality Office at the Public Utility Board in Singapore. Renowned for the new water projects, I believe 3 of them, is that right? More than 3. He keeps building new treatment plants. So he's very well known in the water reuse business for sure. And then we have Paul Gagliardo. Oh, so sorry. Harry is going to have a formal presentation. And then after Harry, we're going to open the mic and let Paul, who's the Manager of Innovation Development at American Water, he's going to have some time to air his thoughts. Trevor Hill is the President and CEO of Global Water Resources. He'll have some time to tell you what he thinks about bringing technologies into the municipal marketplace. And then we should have time for questions from the audience. Paul, do we have a mic?
I think we'll be able to get one.
Okay, either that or he shout out real loud. So this, I think, is the first audience interaction of the day, so we'll see how this goes. If it goes badly, then we'll just shut you off. And I have a few questions as well. So with that, Harry, let's get you going here. And there we are. Thank you, Harry.
Thank you, Andy. Basically, about Singapore, I think if you look at the slides, you can't find where Singapore is. We are very tiny, I think vulnerable, and then being tiny and vulnerable, I think is strength, because it forces us to think out of the box, right? It makes us to look for innovative solution to solve a water problem. Because if you go by conventional way, we are doomed. You know, I think you go by WHO, we are actually one of the most scarce country. Yet, I think what we did is we turned our vulnerability into strength in a way to solve our water problem. Now, new water, example, we came to know about it in 1998 when we came to US. In fact, the idea is from US, not from us. But what we think is, we look at the thing, we like it, we tested it, it works. I think within, I would say, 8-9 years, we increased our capacity to about 120 MGD, which makes up 30% of our water demand. And eventually, as we go into our master plan, we hope to grow it even further. Now, with this new water, in terms of the technology, because we have enough working experience, confidence, potential of the technology, now we have extended membrane technology into water treatment, desalination, pre-treatment, RO, and of course in new water. And within 8-9 years, we have increased our treatment capacity to about 1.2 million cubic meters a day, or 1.2 megaliters a day. So basically, this is what we do to solve our water problem. So basically, idea is good, we believe in it, we will do it in an accelerated program way. R&D approach. We are more into pilot testing and demonstration. And basically, pilot testing and demonstration, when we did that way, it has its advantages because, in a way, it removes a lot of unknowns. Not only from the utility point of view, but also from the technology provider point of view. So, in a way, we reduce risk. And you reduce risk you get better price and lower risk. And when we come an idea, involvements of our operating departments are very important. So from day one, we get our operating department to be involved. In fact, we will identify a team and get them to lead the team in terms of the research. But you notice that I will show you a next arrow that we move, where when we run out of ideas and we need some fundamental shift in our thinking, we try moving upstream to try in a way to change the direction of some of the research, right, in a way to solve our long-term problem. So some of the things we're doing here in the short term is solve a problem, but it's not there yet. So we need something better. So we are beginning to move upstream to try in a way to shift the direction of the research, all right? Hopefully in a way to solve our problem. So we work quite closely with the universities, whether locally or overseas, in a way to get new ideas. Our research is basically problem-centered. We must have a problem. That's why we do research. We are not looking for a solution looking for a problem, but more of a problem looking for a solution. All right? So our problem can be short-term, it can be long-term. Right? So we try to solve problems short-term and long-term. And basically when we look at the whole thing, when we do all our research, basically our focus is more on efficient use of resources. Energy, I think you hear a lot about it just now this morning. Chemicals, and basically waste. In a way, we view waste as not as waste, we view waste as a resource. All right? And basically, in a way to solve our problem. And then, if someone comes to us with the new ideas or anything, basically the idea that we are interested in is basically how can it make us operate better or make our system more robust, all right? So basically what we do is that if someone comes with an idea to us, we will how do we put into our existing system and try to evaluate it upstream and try to evaluate it downstream. Basically, it's a total assessment of the idea, right? Because sometimes some come with the idea as a single process itself, it may be good, but if you derive that low value, you need to do something upstream and downstream, then in the end, as a total system, it doesn't make sense. So that's why in the end, when we look at the thing, in a way what our management will say is like, can we do more with less. I give an example, like membrane bioreactors. 5 years ago, someone came out with this technology. And basically what we do is that now we put it into our existing process, which is the one on the top, right? So in a way, we see the attractiveness of technology is we can eliminate 3 steps and put one. We look at the whole process itself, opportunity for automation, we can derive efficiency of the system, right? But at that time, 5 years ago, any membrane bioreactor supplier come to us, they'll say that the energy is 1.2 kilowatt hour per cubic meter. So if you evaluate as a total system itself, as a utility, we will not use the technology because in the end, the energy used is much more than before. But we see the value of the technology, so the downside is only energy, and that's why in the end, our research, it helps us to define our R&D goal, in the sense that we need to drive down the energy. We have a target number to meet. If we meet the target number, then we know the technology, at least is technology neutral, and after that, we enjoy all the benefits. But I think we got better than we expected. So if you look through all the timeline and everything, I think we drove down the energy down to less than 0.4. And so now, what we have is that many other companies, we work in many other companies, basically in a way to the membrane bioreactors. Also from the utility point of view, we also prefer to have many suppliers. I think our project-wise, we have enough projects to have many players in our even our tiny island in Singapore, right? And these are all the benefits. We got better quality water, smaller footprint, overall energy is less, 0.115 compared to 0.7 as a total system, all right? And from that Singapore context, I'm already saving, in terms of US, is maybe about 2 cents per cubic meter. So can you imagine is, let's say, 120 megaliters, 120 million gallons per day, or 500 megaliters a day, the savings is enormous for us. We are a utility. We don't, unlike other utilities, we actually manage the whole water cycle. To us, water is water. It's not wastewater or used water. It's not seawater. It's not rainwater. It's water. So this way, in a way, when we do research, we try to derive all efficiency throughout the whole water loop. That's how we keep our, in a way, develop new water resources at a lower cost, or not say low cost. Low cost is a wrong word. Affordable cost, right? And through operationally, everything derive efficiency and keep our costs affordable. So what do we need for successful R&D from the utility point of view? All right, we have a roadmap to help us to guide our R&D direction to solve our water problem. Always challenge conventional thinking or approach. Can we do better than what's currently being undertaken? Then talk a bit about intellectual property. We are not fighting with intellectual property. You can keep it. We only want to use the idea as quickly as possible so that we derive our value downstream when we apply the idea or technology. Then the last, talking about trust. Trust is very important, where hopefully when someone comes with an idea, as long as the science is right, we may be ahead of the time, but in terms of don't oversell. So this is a roadmap that we developed over the years to solve water problem. So we have this roadmap. This roadmap is not something that is cast in stone. It keeps on changing depending on any emerging issues or ideas, or someone with a better idea and thing. We always update this technology roadmap. We even have roadmap for desalination. Look at RO itself. You hear a lot about RO being energy intensive. We have a short-term goal to drive down energy to 1.5. We achieve some of them in terms of, example, like membrane distillation, where we make use of, like I said, we don't treat waste as waste, but waste as resource. We use waste heat, and we keep the energy down to 1 kilowatt. Electrochemical desalting, which is done by Siemens. in a way, it was a challenge call. And I think within 5 years, you hear about less than 1.5. But of course, this is still energy intensive, although we still lower it down. So our long-term goal is a theoretical number. A lot of debate about that number is impossible. It's good to have an impossible number to give you a challenge goal, right? Whether I meet it doesn't matter, but as I drive down energy down is a target. And basically, that's where I remember I mentioned earlier, I told you that now we're trying to, in a way, influence the upstream research. So we're funding projects in terms of go back to nature, to understand nature. Maybe nature have a better way to help us to extract water from the sea. So we study the fish, we study mangrove swamps. Wastewater. Based on science, there's enough carbon source in the wastewater to power the wastewater treatment plant. So in a way, we have this roadmap to, in a way, derive 80% energy efficiency in 5 years, 6 years, and in long term to make the wastewater treatment plant energy sufficient from the sludge point of view, from the biogas point of view, and everything. I mentioned earlier about challenge conventional thinking. I give one example here. This is RO cleaning. The conventional thinking is that, okay, you clean the RO membrane is one direction. You need to down the RO drain to clean, and you use chemicals. Now, this idea is not from us. This idea is from Professor Boris Liederman from Israel, right? So his idea is basically is using osmosis, right, to, in a way, to clean the membrane. And we talk to him, we get him involved, collaborate with him. The proof of concept, we prove that it works, but when it works, the salt content initially was high, based on his recommended. So our value to the idea is basically is from the operator point of view, how can I bring down that number such that from operator is easy to handle. So when I put down there 64 kilogram for every 8,000 cubic meter a day plant capacity, initially we are talking about 640 kg. So from 640 kg point of view, no operator will want to touch that idea. So we drove down the thing to 64, and now it becomes a manageable number. Then if you look at the chart itself, the pressure is much lower. Right, so we're talking about 15 to 20% lower pressure. Energy is saved. All right, and basically 15-20% translate to us. From that point of view, from an 8,000 cubic meter a day plant, we are talking about maybe about $200 a day, $300 a day. Right, converts to 64 kg of thing. And the other point of view is that we also increase the production capacity and less chemical use. IP policy, we are utility. We are not in to own technology to compete with other technology provider. We are user technology. So anybody come to us, we are not fighting with IP. IP owns by the provider or inventor. And basically, as I mentioned earlier, PUB aims to benefit downstream. Trust, because I think we built being tangent neutral, we don't compete, we collaborate with many people. I used these slides last time to show how to get ideas, but this slide also in a way to get this many people working for us. I always believe that because we more or less instill a level of trust between each other. In a way, we create a win-win situation. Test bedding. We are very open to our facilities being open for testing on new ideas and everything. And the value of this test bedding is basically you can more or less evaluate your idea or your technology against existing technology in real water. It's a direct comparison. Now, this is when we do all this R&D, basically, and all these figures are independently derived. We got IP consultants that come in to audit us and check on us whether we did anything right, and these are the numbers. I think you look at the last number, we invested about $60 million in R&D, and based on just cost avoidance, efficiency, and everything, we are talking about $200 million a year. So more or less, we pay back for our R&D effort investments. So the question is, why are we doing all this? Like I mentioned earlier, we are a tiny island. So in a way, we want to be energy sufficient. We have to be energy sufficient to survive, right? And while doing that, we are mindful that we must keep our water affordable. That's all I have. Thank you.
I'm tied in. Well, two comments. I had spent some time in Singapore back in the late 90s, working with Harry's group back in the day when he didn't have all of this roadmaps laid out. It seems awfully complicated, but I know these guys are very organized and do a terrific job. One thing I'd like to mention, in your pyramid you showed anaerobic MBR in the next 5 to 6 years. American Water has developed an MBR system, an anaerobic MBR, that reduces energy usage by 57% over existing facilities. So we'll have to talk about that later. You can move that, you can move that pyramid up a little bit and kind of get some more savings real quick. One of the other interesting things, about is a very well-defined roadmap and protocol. That is one thing that's very different that American Water does. American Water has an innovation program of one person. That's me. And I think that's a good start. Hopefully we'll add to that later on, but there is no formal roadmap. I'm kind of a random access innovator. I look at all things that come in and try to provide, give everybody 15 minutes, see if that idea makes some kind of sense and we can fit it into our asset base. So as our program develops, it's only been around for less than 2 years, hopefully there'll be more of a kind of formalized process where things will move forward. Now that being said, innovation really, to embrace innovation, you have to embrace change. One of the key things from a utility perspective is there has to be a change agent at the executive level. If there's not, nothing's going to happen. A lot of times regulations drive innovation. Some new rule on a contaminant comes out and we have to meet that new contaminant level, and that forces some innovation, some new things to happen. In our case, we are driving innovation through performance metrics at the various facilities and the various operating entities that we have. And those performance metrics then encourage the operating companies to try these new technologies, even though many of them are not going to work. A typical venture capital firm may have a 2% hit rate, which is about the number I'm hitting. About 200 ideas I've looked at, and I'm actively working on about 4. Now, there's been a lot of talk about how long it takes to get innovations incorporated into water utilities. I'll tell one story. Back in June of last year, I was introduced to the CEO of a company called Imbala. They do essentially demand-side regulation services. That's too complicated to get into right now, but it's essentially a smart grid, electric grid, water energy nexus, whatever terminology you want to use, technology. We have executed contracts, done a demonstration test, deployed the technology, and executed equity agreements with the company within 1 year. So we've deployed a new technology in a water treatment plant that the operators are happy with, that the ISO, the independent system operator is happy with, that the innovator is happy with, within 1 year. And I think that is really key to driving these things forward. Mark was talking about HTI has been around for 25 years and they're still working at it. And that's, I know, one of the big difficult things with the innovators is how to get these things into the market as quick as possible. So what we do is we try to set up validation, become an early adopter, and move those things forward, but it has to come from the top down. You have to have that impetus from the top down to encourage the operators to try it, and then you have to have those operators who are also innovative to accept that challenge and to work through the various issues. I don't know what that clock means over there. I'm going to ignore it. Okay? I just keep seeing numbers change. The guy set it up to 20 minutes before. I don't know what's going on. Another situation that we had that, just another success story. Over the last few months, we have a situation where, and again, it's kind of IT related, where there are multiple customers off of one service line. So there's a shut-off valve at the service line. So if one of those customers don't pay their bill, you can't shut them off because you shut off multiple customers. We deployed a technology, it's basically a remote-controlled shut-off valve, operated with an iPhone app that was installed for about $100 per unit. We installed 1,000 of these valves over the last couple of months. 850 of those customers, we obviously installed them in places where the customers were not paying their bills. 850 customers, as soon as we installed the valve, they paid their bill. The other 150 customers, as soon as we shut off their water, they paid their bill. So we had received over $230,000 of back revenue. Essentially, we had written it off within 3 months of deploying this technology. Again, it's an example of we have a problem. We look through the, everybody has their list of new technologies that they try to deploy. I looked at my bag of tricks, pull those ones out, try to deploy them and test them in the facilities that we have the problems. And we're making progress in a very quick manner deploying these new technologies, really under a true collaboration. As Harry was talking about, we're technology agnostic. We want the companies we partner with to succeed. We want them to bring value to us. But also, as American Water being a proxy for the water industry, we want then those innovators then to roll those ideas out to the rest of the asset base around the United States and around the world. And if those companies are successful, then we're going to be successful as well.
So let me chime in a little bit on the technology adoption cycle front. Back in the late 80s, I used to work with John Coburn, who's in the room, and we together installed the very first MBRs for municipal water reuse. And that was a very challenging process, selling into the municipal sector. And I think one thing to remember first is that at the end of the day, you want to access the U.S. municipal market. It's 85% dominated by, the water market in the U.S. is dominated by municipal entities. Guys like Harry are extremely rare in the U.S. That is to say, I've never found anyone like Harry in the U.S. And guys like Paul are great. But
like chopped liver?
Let's face it, between Paul's company and my company and all the rest of the investor-owned utilities combined, the market cap is $10 billion. So a rounding error in the context of the U.S. size of the U.S. market. So then the question becomes, what's your business model? What's the channel to market? And through the 90s, after we had some success bundling and packaging from a consulting perspective, Xenon Technologies and others, out of revenge and frustration, I entered the utility business. Really to buy utilities so that we could change the technology footprint. Now I sound more like Harry than Paul or others. And ultimately then became early adopters of technologies from that utility perspective. We could, because we were tech savvy and sort of forward leaning, started to bring in technologies that you hadn't seen too much in utilities, like we had Tower Red AMI 6 years ago, and many other technologies around water reuse. And because we were a regulated utility and we had capital, a balance sheet, that was one way to start to see how these technologies could move forward. When we started our new business Fathom, which you heard about this morning, we started with business model channel to market concepts. And so talk about disruptive. In this U.S. municipal market, really there's only two channels to market. through engineering firms or through rep and distributor networks. The engineering firms, as was mentioned earlier this morning, and there's a few exceptions, maybe Carollo is one of them, but typically they're not very incented to adopt new technologies. And in fact, in the last 5 or 6 years it's been better, but in the 90s it was very, very difficult to have an engineering firm specify an emerging technology. And the rep networks who are out there, and there are many of them, really had a difficult time getting paid to specify a new technology. And so what you have is a huge market. Everyone wants to be in that market. It's an extremely difficult market to crack into. So we did something very unusual. We built a call center, an inside call center. You might know that we're advancing smart grid for water, and basically AMI and those technologies around reading meters, correlating the data, and then defining the data in such a way that we could present that data back in real time to consumers. To do that, we needed to access the municipal market. But historically, 10 years ago, the market was all about water quality. Now, in the last 5 years, it's all about efficiency. You can't talk about quality to municipalities. They're not interested right now. What they're interested in is saving money. So we built a business model that was directed to municipal decision makers, managers of cities. And we made them indifferent to the technologies by bundling and packaging this offering in such a way as to give them visibility to the economics. We put an inside call center in. Our guys make 1,000 outbound calls a week to municipal decision makers. We're making pitches every day to municipal decision makers, municipal finance guys, city managers, in some cases public works directors. And then the model is an outsourced service for back office processes that all municipalities do, and most do poorly. Reading meters, billing customers, managing remittance, things that matter now since the downturn in the economy. And with pleasure, I report that this model is working extremely well. We 10x'd our business last year. We'll 10x again this year. But I think what's most important about this discussion today, and you've heard me say it at other conferences, we were at one a few weeks ago, is that there's not now a shortage of technologies in the water sector, and there wasn't 20 years ago. There is a shortage of guys, commercialization expertise. There's lots of technology guys, there's very few guys who are very focused on commercializing technologies and shortening the sales cycle. It took 10 years to get submersed fiber membranes from bench to full-scale municipal, 10 years. Most companies will run out of cash before they get to the mainstream market. So we have to find ways to shorten that adoption cycle and move the technologies into a scalable platform much more quickly, so that we can get an investment thesis for the guys in the room who are trying to figure out how to invest in this space. And guys like Harry and Paul, and I think Global's on that list, are utility owners who are leaning forward and trying to adopt technologies as rapidly as we can. But from my perspective, I'd like to see more discussion on commercialization of technologies, channels to market, business models that are disruptive, so we can break the cycle a little bit in terms of how things have always been done, which are totally frustrating, and start doing things that are a little bit unusual, like having companies like the two gentlemen sitting beside me leading the market, and then seeing the benefits of those spin off to other like municipalities with similar issues. So, yeah, maybe a bit controversial, but those are my views on the thing, and I think it's very important that we start introducing in these conferences that dynamic. Let's talk about channels to market, let's talk about disruptive business models, and see if we can't compress that hideously painful sales cycle that we all deal with.
So we just have a few minutes here, Paul. I know we'd like to go longer. Do you have an extension? Can we get an extension? No. So I guess, what I'd like to do is follow on Trevor's thought there and ask Paul and Harry and even Trevor, you can respond yourself. I've seen a number of very exciting technologies that have had initial startup money, have brought technologies across the Atlantic to the United States, done demonstration testing. Their investors start getting impatient. The first facility isn't built yet, and at some point they pull the plug. And this whatever treatment technology might have had a 20, 30, 40% savings compared to existing systems. So is there any advice to the inventors to try to cross that valley of death? And how do you get to be in that 15 minutes of fame on your desk, Paul, where they can have an opportunity to succeed?
Oh yeah, they get 15 minutes even if they've got a piece of crap. It's, I wouldn't know, until the 15 minutes is up. I mean, that is the key question. The way I like to go about it. I mean, American War is not an altruistic company, but we really believe in true collaborations. Both sides have to put some skin in the game. We're willing to do all the testing on the product and define success criteria on a new idea that says, okay, we'll test it. You give us a piece of equipment, we'll test it. We'll run it through its paces. If it meets this level of performance, then we will move forward and become an early adopter of that technology, so that the innovator knows that there's an end game where there'll be a product will be put into place if this criteria is met. And so we work hard at defining the experimental plans, defining the criteria for success. We get everybody internal in the organization to agree to that and to the innovator, and then we move forward. And if the test plays out and things work and the success criteria is met, then we move forward with the engagement to procure the equipment or procure the system. So that's one way to try to leverage the testing and the eventual outcome of successful deployment of the technology. So we try to link those things together so that the innovator is willing to put time and effort into it, as we are, because they know they'll get something out of it. And if they believe their product works, they shouldn't have an issue with putting some skin in the game.
Okay. I think talking about the valley of death, I think any new ideas start from a low base. So basically, cost to you is maybe relatively high. So I remember earlier in my presentation that I'm more focused on is on resource utilization. Basically, if your system is utilizing resources efficiently, there should be a market. All right. So I'm not that concerned about capex initially. So if in fact we are even prepared to even pay 10-20% above current conventional capex to get the idea off the market. Because if you look back at historically, go back history, you look at RO itself, reverse osmosis. I think 10-15 years ago, you're talking a few $1,000s per element. Now, we are talking about, I'm getting it for about, I think US dollar, maybe $500-600 per element, right? And it's better quality, lower energy, and everything, right? So in a way, you must have faith that the idea is good, resources are used efficiently, the market will grow, the costs will come down. So our part to play in this valley of death is basically as a utility, we're prepared to pay a premium over your current capex, over the conventional capex, so that we can move the idea forward. All right? That's what.
Paul, I think we have to wrap up this session.
Sure.
Yeah. So I guess we have the transition here. And thank the panel. I appreciate all the time.